Hello, my name is Scott from MecSoft Support, and in the next few minutes I'm going to take you through some of the functionality and features that you will see in the new nesting package of VisualMILL 2012. This demonstration will focus primarily on the true shape nesting. First, let's take a look at what you need to do to prepare. Before going to the nesting software, you need to bring together and locate on your screen those shapes which will be involved in the nesting process. You need one or more shapes that represent the stock material or remnant. You need one or more shapes that represent the production parts that you wish to be nested within the stock material. This is sometimes referred to as staging the parts. I have two tips for you when you stage your parts. Number one, don't stage a part within the stock material. Keep them all outside of the material. Number two, don't stage small parts within larger parts. Keep them all separately spaced. Okay, the parts are staged. Let's go to the nesting software. I will choose VisualMILL on the menu bar. The third option is Nesting Browser. The browser comes up on the left of your screen and gives you a choice of true shape nesting or rectangular nesting. We want true shape nesting because that's what we're demonstrating. And I'd like to point out that there is a help button on each one of the pages of the nesting browser. If you select that, it brings up the documentation and gives you instructions on the current page of the browser where you are working. I will now select the stock material. Pick Select Curves, select the shapes that represent the stock material. Right mouse button completes that selection and enters the entries in the table. Sheet 1, Sheet 2. I have, let's say, 2 sheets of each of these for the sake of nesting. These parameters up above, Start, Corner, and Nesting Direction, give you control as to where the nesting should begin and in what direction it should proceed. This is good for remnant control. Grain direction I will come back and explain in just a little bit. Likewise, I will select the parts to be nested, pick Select Curves, select the geometry on the screen, and when I'm finished, right mouse button will accept those, and then I'll do the interior geometry just by windowing it. Again, right mouse button will enter those into the table on the browser. So here's another tip. Selecting the exterior shapes of all the parts first forces them to be at the top of the list in the table on the browser. This makes them much easier to find when you need to change parameters such as count, orientation, and grain direction. The interior geometry can be at the bottom of the list because you will never change parameters for any of the interior geometry. Now I will enter the count for each one of the parts that's needed in the nest. There are 3 control options that can be specified down below and will apply to all the parts. I'm going to change the incremental angle to 45 degrees, meaning that the nesting software will attempt to rotate any of the parts in 45-degree increments to achieve a better fit. I'm going to allow mirroring of parts, and this option will allow smaller parts to be nested within the cutouts or holes of larger parts. So if you have a part that you do not want rotated or mirrored, such as this one, you can select the fixed orientation and it will be maintained exactly in the orientation that it is staged throughout the nesting process. There is one more step then before creating the nest, and that is to specify 2 spacing parameters. The first one is the distance between adjacent parts. The second one is a distance between the outermost parts and the outer edge of the material. With those settings, let's execute the nest, preview the nest, and you'll notice that 3 sheets will be used. And there's that part that was fixed in its orientation, exactly as it was when it was staged. The last thing I'd like to do is impose a grain direction control on this larger part. In order to do that, I must specify the grain direction on the stock material as well as that part. For all of the stock in the table, I will set the grain direction to along X. Now I will set the grain direction on the part to be along Y. I'll re-execute the nest, preview the nest, and you'll see that those parts were aligned vertical now. Let's look at the other sheets. Each time a nest is generated, the system will calculate an efficiency factor or percentage utilization of the stock material. Once you are satisfied with the layout of the nest, you will select the Commit Nest button. That writes the geometry of the individual sheets onto individual layers in your current CAD part file. These then can be used for machining applications or any other application that you wish. There you have a summary of true shape nesting in 2012. Thank you very much. Happy nesting.